So I will hand you now over to someone you should know very well, Professor Ron Boschma, who we are pleased to have among the visiting faculty at the University of Stavanger. And he will be the chair for this opening plenary session. So please, Ron. Yeah.
Working? Yeah, all right, okay. Yeah, thanks a lot. Thanks a lot for the introduction, and welcome to all of you. It's great. We have a full house here, I see. So it's so great to see many of you, colleagues and friends, and I'm really pleased that you were all able to come at the end of January. Right, well, we're all busy with teaching and things like that, and but we managed to get out of that and come here and participate and attend this wonderful conference. If I look at the program, it's really impressive, right? So so many papers, so many parallel sessions, so great keynote speakers. So I'm really looking forward to that. Of course, on behalf of the organizing committee, I also welcome you all. It's great to have this 5th GEOINNO conference after being held for the first time in 2012 in Saint-Etienne. This is already the 5th one, and I think we have proved that indeed it attracts a lot of excellent scholars, and that the community of Geography of Innovation is really big. So that's really fantastic to see. Okay, I'm here just to briefly introduce the two keynote speakers. They're, of course, everybody knows them already, and you're very familiar with their work, so I keep it very briefly. We will start with Mercedes Delgado. She is, and now I have to put my glasses on. She's Associate Professor of Strategy and Innovation at the Copenhagen Business School. Yeah, she just moved there. And she's also affiliated to the MIT Innovation Initiative, and she's also Senior Associate at the Institute for Strategy and Competitiveness at Harvard Business School. In the past, she obtained a PhD in Business Economics in Madrid, and has also been a postdoc at Harvard Business School, and has been Senior Lecturer at MIT Sloan School of Management. We all know her very well from a number of key contributions. The one that I always liked a lot and was very inspirational also for my own work, the work on the role of regional clusters, right? Very original contributions, how to map, how to define industry clusters, and now more recently you also moved into supply chain. So I think all the work you do is excellent. So we are very, very pleased to have you here as the first keynote. So I invite you please to come here and take the floor. Mercedes.
We're good? Yes. All right. So this was exciting, and hopefully the presentation is going to be even more exciting. Today I'm not going to talk about industry clusters, just a little bit. So thank you, Ron, for such a nice introduction. I'm going to talk about a topic that I think is crucial. You know, the fact that we have very few women engaged in patenting as of today. All right? And this is joint work with my dear co-author, Fiona Murray, at MIT, where she's also the Dean of Innovation. And this project has been supported by a grant from the National Science Foundation. So very happy to share that work with you. As Ron was mentioning, a lot of my work in the last decades, well, no, last decade, it's been on the relationship between location and the performance of firms, cities, and countries. So at the 3 levels. And more recently, I'm also now looking at the role of location on the performance of inventors. So today I'm going to talk about inventors. And I had a fantastic opportunity to reflect about my own work and how it relates to the work that many others have done on industry clusters and performance in a fantastic book. is the new Oxford Handbook of Economic Geography that was just released a year ago. And I'm looking at Maric because what an effort, right, by the editors like Gordon Clark, Marian Feldman, Maric, Gertler, Darius, in putting together this book. It has more than 50 chapters by different authors. And since this is a conference on the geography of innovation, I figured I have to mention this book, okay? All right, that also helped me transition to the topic that I'm going to discuss today. And it's very easy to motivate, right? The motivation is the missing female inventors. In particular, I'm going to be looking at inventors in the US. An inventor is going to be an individual that has a patent granted to an organization, and it's going to be a utility patent granted to an organization. And the organization can be a firm, a university, and so on. The first thing we did in this project is that we created a name-gender matching algorithm. To do that, we use a list of MIT names and self-identified gender, and we also use a very long list of names from the Social Security Administration. We created this algorithm that's going to be publicly available for everyone to use. And once we're able to do that, to identify the gender of each inventor in each patent, there are many questions that we can look at. One of the first thing that we do is to create some, what we call female inventor inclusivity scores. And there are two ones that I'm going to discuss today: the percentage of female inventors and the percentage of female new inventors. What is a new inventor? It's someone that got their first patent granted. Imagine the time you publish your first paper, and suddenly you were like, yeah, I'm an academic researcher, right? I was able to publish one paper. So here is the same thing. It's the first patent that you get granted. That's what defines you as a new inventor. Now, what is the sad news, but also at the same time the opportunity here, is that as of 2015, only 10% of all the inventors in the US were women, only 10%. Now, there is a similar gender gap. This is not just the US. There has been also other very relevant studies looking at this in other countries that find similar numbers in many other European countries, Asia, and so on. To me, the most worrisome part is not that the level is low, is that this gap is very persistent. Even during our time period, from 2000 to 2015, the percentage of female inventors has only improved by 2 percentage points, from 8% to 10%. We actually estimate, based on the annual trends of this score, that it will take more than 250 years to reach parity in the percentage of female inventors. I think everyone in this room agrees that that's too long, 250 years, right? So how can we reduce that number? So that's going to be the whole motivation of this project, how to accelerate change. Who are going to be the catalysts? Who are going to be the institutions and the people that are going to accelerate change so that women participate more in invention and in patenting in particular? Now, why do we care? Well, inclusion in the innovation economy is not only an economic goal, it's also a social goal. We know that it's one of the UN SDG goals. The goal number 5 is gender equality, right? We want a society that has equality, and part of that is gender equality in opportunity, in innovation, and so on. There's some music. The second reason we care, and we know that from prior work, is that we're missing a lot of inventors, right? If women are not choosing STEM skills, it means that we're losing a lot of those potential inventors to be. But I think actually the problem is much more than that. It's a problem of inefficient use of talent. So there is a lot of women that have STEM skills, but they are not showing up in the patents or in other, or in entrepreneurship, or in other type of commercialization of inventorship. And finally, it can also be a sign of there are barriers for women to innovate, and there is a poor innovation culture in organizations that is preventing women to patent. Now, a lot of people, when I present, I shouldn't say a lot. It's only a few. Often I get this comment, is it because women don't want to patent? They choose not to patent. But the reality is that these women are choosing to do PhDs in STEM in the top universities, right? These women, also there is prior work by, especially by, there is a very important paper by my co-author, Fiona Murray, and Dean and Stewart, that actually shows that if you reduce some of the barriers to the commercialization of invention, such as better access to technology transfer offices, access to corporate boards, grants, we actually see that female faculty increase patenting. So once you reduce the barriers, they start patenting more. So it's not just about a choice, I choose not to patent, okay? So hopefully I have motivated that we want more Margaret Knights, okay? So let's put this in the context of the bigger project. In this project, what we do is mapping all the inventors in the US, and we are going to build a female inventor inclusivity scores across cities, across different types of organizations, for top inventors, and over time. And then what we do is to use that data to answer different types of questions. In the prior Geography of Innovation conference, I presented this question, what was the role of location on the inventor gender gap? So today I'm not going to talk about the same thing, but let me summarize very briefly what we found on that particular part of the project. In that project, we tested the hypothesis that women are more geographically constrained, meaning that they cannot go too far away to search for knowledge. That could be because of family considerations. It could be because they have fewer resources to travel. It could be because the firms are not offering the same opportunities to the female versus the male scientists when it comes to travel and to create multi-location teams. To test that hypothesis, if it's the case that women are geographically constrained, it means that they're going to have to find a different way to source knowledge. In particular, they have to search for knowledge that is close by. And that's what we find, that the female inventors are much more likely to collocate geographically with the rest of the inventors in the team. So they need to be very close to the collaborators, okay? Now, that is ongoing work, so there is a lot of additional work that we have to do, but that is very important for us people interested in innovation and economic geography, because it means that perhaps these women scientists, they cannot benefit from the temporary proximity because they don't have the same opportunities to travel, to temporarily access the knowledge. So it means that the choice of the right location for them to live and work is going to be very important. And as someone that looks at industry clusters, I do think that part of the right location is going to be in a location where there is density of knowledge, in a location where you can more easily collaborate with other inventors. So I'm thinking of course, someone that looks at industry clusters, I'm thinking of industry cluster. But this is not the topic of today. Today I'm going to talk about the role of universities in engaging women in patenting. This is this paper as I mentioned with Fiona. And in order to develop this research agenda, we have been trying to reach out to a lot of different organizations, and in addition to the research community. In particular, we've been talking to inventors at MIT to hear from them how they create teams. We've been engaging with the USPTO, presenting our work, the OECD. Here in Europe, one of the experts in how to work with patents, right, are in the Max Planck Institute, and I had the opportunity to interact with them, and we're hoping to work together to look at the gender gap in Germany. But we're also talking to big firms, right, because firms, like for example, Cummins, they patent a lot, but they want to engage more and more their talented women in their patents and in their innovation. So we're also collaborating with some firms. Okay. Now, so what are the key questions that hopefully I'm going to answer today? It's a very simple question. Are universities catalysts for inclusion in innovation? A big question that I'm going to break into 4 smaller questions, all right? And those questions are, the first one, are patents by universities more inclusive than the US economy? The second question is going to be, is the inclusivity of universities aligned with the supply that we have of women with STEM PhDs? The third question is, what is the role of the top inventors within universities in catalyzing change? And the final question, is there a difference between female top inventors and the male top inventors in their inclusivity? So those are the 4 questions. Now, why, you may be thinking, Mercedes, why universities? They create very few patents, let's be honest, right? It's 4% of all the patents in the US are granted to the universities. However, universities are training the majority of the STEM students, right? So they have the whole supply for them to train, and that's extremely important. Also, as we will show in this paper, universities are creating a lot of new inventors. And this is very important. Why? Because we know the university has this unique opportunity to influence students very early on and scientists very early on in their career. And this can have very long-lasting effects. In economics and in innovation, we call it imprinting effects, right? So there is going to be an imprinting effect from your mentor, your PhD mentor, to the student. And those have very long-lasting effect in your long-term productivity in your career as a scientist. And there is some very good work about that, for example, by Pierre Azoulay and co-authors. Now, think about it. If universities create a lot of female new inventors, now when these female inventors go to work on firms, they have already reduced some of the barriers. And now they have the opportunity to become more productive inventors in their overall career. This is also, think about the externalities this can have in the whole economy. The majority of the women and men that get a STEM PhD, they don't stay in universities. We think that, in economics, most of us, or many of us, stay in the academic world. In STEM, 60% of them are going to work on firms. So it's very important that if we change their skills and their expectations about being innovators early on, that's going to have a very long-lasting effect and an important effect in firms. Now, what is the sample? We are going to look at, because we're interested in catalysts, we're going to focus on on universities that patent a lot. Specifically, our baseline sample is going to be the top 25 universities. these 25 universities, 25 out of 200 universities, so it's only 12% of the universities, but together, they generate more than 50% of all the university patents, okay? So they're going to be very, very important. Plus, they have the majority of the top academic inventors. So what do we find? So I'm going to... When you look at this table, you can already see some very good news. The universities have much higher inclusivity than the US economy, both in terms of the level, but also in terms of the growth. If you look at the percentage of female new inventors, it's 22% in the universities, here we are, and it was 14% in the US economy. A difference of 8 percentage points. That's a very large difference. You also see that the rate of change is faster for the universities than for the US economy. So those are the good news. Of course, we need to control by technology class because the patent composition of the US and universities is very different. So universities, almost 50% of the patents are going to be drugs and medical. Drugs and medical is 15% of the US economy patents. So we do control for technology class. We also build some indices are going to be very important. These indices are going to be weighted averages across technology classes so that we can better compare the universities to the economy and compare also across universities. So we find the same good news. Here is the not so good news, right? Even if universities are doing better, still it will take them 169 years to reach parity in the percentage of female inventors. So this took us to the next question, right? Is the constraint the supply of women with STEM PhDs? To answer this question, actually, this took us to a very important finding of this project. We needed to ask the question, who is participating in the university patents? Are PhD students part of university patents or not? Some very key innovation scholars were very skeptical. They thought they are too young to be filing a patent while they are doing their PhD studies. However, I'm guessing we have here a lot of PhD students. I'm guessing many of you has as a goal to submit a paper to a good journal during your PhD studies. So the same thing here, but instead of submitting to a journal, I want to be part of a patent, right? However, we needed data and evidence because we couldn't find a paper that we could cite. Of course, Fiona, observing many of the inventor teams and labs at MIT, she knew this was the case. The PhD students participate in patents, but we needed to come up with some evidence. So what we did to come up with evidence, the first important point is that these 25 universities in 16 years, they are creating more than 20,000 new inventors. Think about it, 20,000 new young inventors that can change the world, okay? But now we want to know, who are they, right? So what we did to figure out who are they, first we took a random sample of those 20,000, 5% of them, and we searched them online with the help of fantastic research assistants to figure out what was the work status when they filed the patent. And what we discovered is that 42% of them were indeed graduate students when they filed the patent, and 9% were postdocs. Then for MIT, after signing a lot of paperwork, we convinced MIT to give us access to the data with all their PhD students, inventors, communication between the technology office and the research office to figure out that number for MIT. Now will be the exact number, it's not a random sample. In MIT in 2015, 48% of all the new inventors were students, okay? On average, students represent 26% of all the co-inventors in one patent, meaning that if you have a patent with 4 inventors, 1 is going to be a student. This is extremely important because this means that indeed universities can have this very long-lasting effect, right? They can intervene very early on, creating these new inventors that then they're going to move on to work on firms. Now, but the key question, is this opportunity equally available to the female PhD students versus the male PhD students? So let's look at that. So here's the answer, and I think in this paper there is always some good news, and then there is some opportunities, okay? And the good news, when you look at the universities, first, as we knew, they're doing better than the US, but when you look at the percentage of female STEM PhDs, in these top universities, the share has been increasing very fast in the last 16 years, okay? By 2015, 34% of all the STEM PhDs were women. So that's the good news. The not so good news opportunity is that when you look at the percentage of female new inventors, it's been improving, but much more slowly. And by 2015, the gap between these two numbers is 1.5 points. So that means that every year we're losing a lot of female new inventors, okay? Just to give you an idea of that, here are the good news. We will reach parity in female STEM PhDs in 22 years. So now we went from 250 years, 169, now 22 years to reach parity in female STEM PhD. However, it still will take us 100 years to reach parity in female new inventors. Okay. So then, of course, you may be thinking, well, maybe varies by technology class. So what we did next is to look at the field where we have more women. So where the supply of women with a STEM PhD is huge. So you cannot say that it's a problem of supply. So what happened here? So even in this field, the field of drugs and medical, there is a large inventor gender gap. This is the field where we have the highest inventor inclusivity, so almost 30% percentage of female new inventors. However, although that number looks very good, it's really bad when you compare it to the supply, to the share of female with a STEM PhD that was 54%. So you see there a gap of 24 percentage points with the supply of women with STEM PhDs. So this is important. Why? Because there is a very important work by Bell, Chetty, and co-authors telling us that an important driver of the inventor gender gap is because women don't have role models, they don't choose STEM education, and that's why they don't become inventors. And that's part of the challenge. But the challenge is beyond that, because I have just shown you that the supply of female STEM PhD have been increasing very fast. However, we don't see such a change in the percentage of female new inventors. Now, so that took us to we already covered 2 questions. That takes us now to the third question. Now we're going to look at, within the universities, who are the people that are engaging more female STEM PhDs into patenting, okay? And we focus on these top inventors, because why can they be catalyzers? These are, when you look at university patents, they are very skewed. So a few people contribute to a lot of the patents. In particular, in this project, we define a top inventor as someone that has more than 7 patents granted during our time period. Why 7? Why not 10? 7 is the percentile, the 90th percentile, so it's really high. And we try other cutoff, right? But 7 is a very high number. Now, these top inventors in the universities, that are 2,200 of them, they are 6% of all the inventors in universities, so a very small number, 6%. But they are listed in 60% of the university patents. So they're creating a lot of teams. In addition, their patent proficiency, their reputation, their autonomy gives them a very important role in inclusion in patenting, right? Furthermore, the majority of them are going to be faculty. Some of them are going to be PIs of grants, PIs of labs. So they are training, right? They have this very important role of training these inventors to be. Now, what do we find? So in order to figure out whether top inventors are more inclusive than the non-top inventors, what we do is that we're going to compare patents that have a top inventor with the patents that have no top inventor, okay? Of course, we control for attributes of the patent, when it was issued, the technology class, the university that is assignee, and so on. And you can already see that patents that have a top inventor have a 2 percentage point higher percentage of female new inventors in their patents, okay? The next thing that we're going to do is that we're going to separate the patents with a top inventor in 3 types. Do they have a female top inventor? Is that a mix of male and female top inventors? And the last one, they only have male top inventors. And I'm going to, rather than show you the table that has too many numbers, I'm going to illustrate those estimates in this figure. Right? So this is the result I just showed you. Patents with 0 top inventor, they have lower presence of female new inventors. The patents with top inventors, they do better. The gap is 2 percentage points. Now, when I break these patents into the 3 types, you can see that whether it's a male top inventor or a female top inventor in the patent, they're both doing better than the patents that have no top inventors. So both male or female top inventors are catalysts, okay? They engage more young female PhDs in their patents. However, you can already see here this difference, right? The difference between the blue, patents with a male top inventor, and the pink, patents that only have female top inventors. And that difference is statistically significant. So that's going to take us to the final question, an important one as well, right? Is there a difference between the female and the male top inventors in how inclusive they are? So what's the theory here? Why could female top inventors be more inclusive? One theory could be homophily, right? We know from prior work that cultural similarity plays a role in how you create teams. And those teams can be teams for a startup, research teams, and so on. We also know that homophily is going to be especially important when you have underrepresented groups. And female inventors and minorities are underrepresented groups, okay? The other factor is mentorship. So there are some recent very good papers that look at that actually mentorship by female faculty to female students make those female students much more productive in terms of their paper productivity. So they are not looking at patents, they're looking at research papers, okay? And it actually can have a very long-lasting effects in their careers. All right, so we take this to the data. How are we going to take this to the data? Now we're going to compute the inclusivity scores for each of the top inventors in our sample. So here is an example from MIT. Professor Karen Gleason, she's a professor of chemical engineering. During our period, she had 19 patents granted. 11 of those on chemical and the other in other technology classes. She co-invents with many PhD students, 18 of them. Think about it, 19 patents, 18 PhD students. She also was extremely helpful. We sent her the whole list of all her patents, all the inventors, for us to tell us, for her to tell us who are the PhD students. She answered 2 hours later, okay? But that's because she identified with the problem, right? Female top inventors are a minority. They are 9% of all the top inventors. So now what we do, what we illustrate here, is going to be the scores, right? For example, for the female new inventors, and we have to exclude all the top inventors from her co-inventors, her score is 41%, significantly higher than the average for the 25 universities. And then when we do the index, and remember the index is very important because these top inventors have patent in multiple technology classes, they specialize in different technology classes. So the index is telling you how well you do relative to the US, once you have normalized all this. She has 29 percentage points better, right, than the US economy in terms of inclusivity for this particular score. So we do this with all the top inventors. So this is going to be the dependent variable that we try to explain. Now, what I love about projects is when you have to always show the results first in the simple means, right? There is no controls. These are just simple means and t-tests of the difference of the means. And you can already see, right, that there is a statistically significant difference between the female and the male top inventors in the 2 scores, the percentage of female inventors and the percentage of female new inventors. And what is very important is that the gap is higher here. And these are the type of inventors that need more mentorship, right? Female inventors is going to include senior inventors, but when you look at the female new inventors, these are the ones for whom mentorship is particularly important, and there the gap gets even larger. Of course, we control for the technology classes, we do the indices, and then you have to take it to a regression. This is the simplest version of the econometric model. We look at the inclusivity of the top inventor as a function of the gender, whether you are a female or a male top inventor, and then some very basic controls. Your university, and what's your main technology class. And rather than showing you the numbers, although you already see them here, right? Let's look at that in a figure. The pink bar are the female top inventors. The blue is the male top inventor. You can see always, no matter the score, and whether it's the score on the index, the female top inventors are more inclusive than the male top inventors, especially when we have de novo inventors, around 6 percentage points. Look at also that the gap is the same if I use the index, so that gives us a lot of confidence. So we know that this difference between the female top inventors and the male top inventor is not because of the technology class. It's also not due to positive discrimination. So these female top inventors are not oversampling the women STEM PhD. How do we know that? Because when you look at this score, 28% for the female top inventors, 22% for the male top inventors, they're both lower than the share of female STEM PhDs across these 25 universities, which is 30%. So this is not about the female or the top inventor doing this positive discrimination. Now, I think that, of course, we do all sort of controls in the paper about the age of the inventor, how prolific it is, and so on, and the findings are robust. But I think that the key piece of evidence then is when we look at this by technology class. So when you look at here the fields where you have a lot of women, drugs and medical, chemical, you can see that the gap is still very important and statistically significant. And why is this result important? Because homophily should be very low in fields where you have a lot of women already. Okay? However, even in these fields where there are tons of women, we see a big difference between the female top inventor and the male top inventor in how they engage women in patenting. So this is suggesting that the mentorship, the female top inventors are offering better mentorship opportunities to these women students. Now, I will conclude. So I haven't been looking at a clock, so I don't know how I'm doing. But I'm going to try to reflect. I need to cut very quickly. I hear. So how will I conclude, right? So how can we accelerate inclusion, gender inclusion in the innovation economy? We have to support universities. Universities are catalysts for engaging women in patenting. In particular, the top inventors are catalysts, and especially the female top inventors. So what could be some of those initiatives? Very quickly, we need transparency, so we can know who are the universities that are doing better, who are the inventors that are doing better. We should use the metrics to celebrate those that are being more inclusive. We need to increase the number of female top inventors. Right now, they only represent 9% of all the top inventors, and we just saw that they are key catalysts. That means that we need to provide them better resources to commercialize innovation, reduce some of the barriers. Number 3, we need to improve the inclusivity of any top inventor, right? Remember that we need to accelerate change. So to do that, we need to figure out what are the best practices in engaging women in innovation and in patenting. Talk to those top inventors. Figure out what are the best type of networks, the best type of practices. We need more resources and grants for female PhDs, okay? Because we know that if they are part of a lab, and then they are more likely to become inventors. And what I want, since we're in a group that cares about externalities, all these initiatives that we do to support universities can have very important externalities in the whole economy, because these new female inventors are going to be working in firms, and also because if these female new inventors are inclusive themselves, this is going to have additional externalities when they create their own teams, when they become female top inventors themselves. I think with that, I say thank you to all of you, and look forward to the questions now. Thank you.
All right. Thanks very much, Mercedes, for this very inspiring talk and putting this on the research agenda, this topic. Okay, we have a few minutes left, so I've probably room for 2 questions. So please could you introduce yourself and just pose the question in a very short manner. Yes, Ernest?
Oh, God.
I think you do.
Ernest Miguel from the University of Bordeaux. Thanks, Mercedes, for this very interesting presentation. I wanted to introduce or suggest you also the topic of migration, and particularly migration policy. When I saw this in the second point, you mentioned that many of the women inventors produce their patents during the PhD and postdoc. I remember the Paulo Stefan numbers that around 40, 50%, and 60% of postdocs are foreigners. So many of them might be doing their PhDs and postdocs in the United States, and then forced to come back because of the type of contracts they have with their origin countries, but also because of the immigration policy in the United States. I'm wondering whether you consider all these things, and also as a policy.
I think it's an excellent point. So far we know that many of these new inventors that the universities are creating are students, and as you very well said, these universities are very diverse, and their students are coming from everywhere in the world. So if we want to support these new inventors that are going to have long-lasting, productive inventorship careers, we definitely need to be thinking about immigration as well. Now, in terms of the data, it becomes very complicated, as you know. For example, the USPTO is also now very interested in how to improve the presence of minority in patents. And it's just very hard because it's not something we can figure out anymore from the name easily, because you could be a second generation. So in terms of data, it's a very good challenge, but it's a challenge that this room can take, right? But I think it's a fantastic comment. Yeah.
Hi, Mercedes. It's Kieran Flanagan from the University of Manchester. Thanks so much for a really fascinating presentation and really valuable. And I'm sure all of the mechanisms that you've hypothesized here are really important. But I wanted to ask, have you looked at, or do you plan to look at any measures of the quality of patents?
Mm-hmm.
Because obviously we know that university patents are often never exploited, they're never licensed. And of course, one explanation here might be simply that men are much more likely to overestimate the value of their patents relative to women.
So another excellent comment. So we thought we needed to start with the rate of participation because let's ignore for a moment quality. The fact that you already are officially an inventor. I mean, there is many other ways you can be officially an inventor, right? You can be an entrepreneur. Maybe, maybe there is other ways, but patents is something that we observe. And the good thing is that if these young female new inventors now have the hat that I have this granted patent, we haven't checked the quality yet, but it was granted, right? Now when they go to their next career step, whether it's in academia or in firms, no one is going to question that they don't know how to patent, right? Because they already have that hat. Now, of course, we should be looking as well the quality. Also, what is the role in the patent? So maybe by looking at the position of the student in the list of inventors, does it come first? Does it come last? With all the problems that is with that. We also should be probably looking at publication patent pairs. Are they maybe appearing in the papers? And there was a recent paper that actually found that women get disproportionately dropped from the paper when we look at the patents. Lawyers will say, no, that's impossible, that's illegal, right? But we need to understand if that's the case. Why was driving that? There may be some good reasons for that. So I think there is all sort of follow-on research to understand these channels so that we can catalyze and accelerate this change.
Okay, thanks very much, Mercedes. I have to leave it to this, because we're running a bit out of time, and of course we would like to also to give the floor to our second keynote speaker. Thanks very much.